Hey guys, welcome back. Today we are diving into more than just building a 3D printer. We'll explore how it actually works. From the study aluminum bars to its electronic brain, we'll break down every part step by step. So without any further delay, let's begin. As the name suggests, a 3D printer is a magical machine that can print 3D parts by melting down plastic and precisely placing it layer by layer. The one I built was very complex and difficult and it took lots of time to build. So in this video, we are not going to see how to exactly build this design, but how you can build any design, something like this. So building that 3D printer starts with making the frame of it. I built my 3D printer from this aluminum extrusion bar. They are available online. They mainly come with two types, the T type and the V types. If you cannot see the difference, the V type has a angled cut like a V and the T type has a flat cut like a T. Though both of them can be used for making the frame, but the V type has a special purpose. It allows something to glide over it with the help of these palm wheels, like our Z-axis gantry or X-axis gantry or our heat bed. This clip shows how the V-type is better with palm wheels. As my heat bed is 200 by 200 mm, my base frame should be around 200 mm more, and as I want my printing height to be 300 mm, my 3D printer height should be around 500 mm. Now as we have brought our aluminum bars, we should grab our blueprint and start building it now. This is the blueprint of my newer model. You can have a look if you want. But one thing I would like to emphasize is my heat bed is 31 cm. So I am choosing 500 mm aluminum bar to make its base. So why it is 52 cm? Because the aluminum bars are not lying. They are actually 3D objects. So when we put them in position, their thickness also adds up. So 50 plus 2 becomes 52. And these are the side view and cross section view. You can have a look if you want. Now let's grab our T-bars and make the base frame. But putting them is not enough, we have to connect it anyway. I will recommend using this corner bracket, M4 bolt and a T-nut. These are made specially for 3D printers and are widely used. So let's see how to connect these two aluminum bars. Well, that was a long silence, but thank you Ania for being with us. And I forgot to mention that there are two types of T-nut, one is sliding and one is hammerhead. While the hammerhead nut can be inserted from any side, but you have to put the sliding nut only from one end. The sliding nut has a benefit that it can hold more weight, but it has a drawback that if you have your endings closed, you cannot put your sliding nut back in. So in this case, you have to get a hammerhead nut. Well, hammerhead nut also has one problem. It sometimes falls off from the bar, especially when it's upside down. So that's it for now, and I will let you build your own design, and it's interesting when you do it for your own. So let's move to the next topic. Do you remember when I said we use the V-bar and the palm wheel for a smooth motion? Well, many linear rails are also available for the same job. They are better in containing the motion in one direction, but they come with a higher price. And these stainless steel smooth bars and these linear bearings are also used for the same purpose. You can put those stainless steel bars in those shaft holders, and the linear bearings can freely slide through them. Then you can mount any gantry plate on the mounting holes of the linear bearings. Then you can mount your heat bed or your extruder, and it will move freely over the restricted one axis. In 3D printers, parts are mainly moved by two things, either by timing belt and pulley or by the lead screw and nut. While timing belt is used for x-axis movement or y-axis movement, if they require more speed, the lead screw will mainly be used for moving in z-axis, as they need to lift a very heavy load, but in both cases, they needs to be connected to a stepper motor that actually converts electricity into motion. Oh yes, stepper motors. These motors are used for precision application like CNC, robotics and more, especially in 3D printing. These motors don't move continuously, they move in steps. For example, if you see this 4-step stepper motor, it moves in 4 steps. Step 1, step 2, step 3, and step 4. No in between, no room for error. So now for a 64 steps per revolution motor, the motion seems very accurate and precise. If you think that was impressive, our NEMA 17 has 200 steps per revolution with 48 watt power, perfect for a 3D printer. The pulley and timing belt for 3D printers has a code name GT2, and most of them usually directly fit over the motor. But the lead screws are usually 8 mm, so you might need to buy a shaft coupler like this. With some calculation, we know that the lead nut moves by 8 mm under one rotation, so it takes 200 steps per 8 mm or 25 steps per 1 mm. Similarly, for a pulley belt, when a 20th pulley rotates by one rotation, the timing belt gets pulled by 20th distance or 40 mm, and again as we have 200 steps per 40 mm or we have 5 steps per 1 mm, thus we have a 5 steps per mm setup. Stepper motors usually comes with 4 wire, 2B, 2A, 1A, 1B. They all go to this device called stepper motor driver, and this is the actual part that drives the motor, and they come with this cute little heatsink that I say you should put it before using the driver. This is the pinout of the A4988 model, the one I currently have, and if you remove all the power and manual control line, there are mainly 2 pins left, step and direction. While direction chooses which way the motor rotates, the step chooses how much the motor rotates. Like for 1 pulse, the motor rotates by 1 step, unless you have activated the micro stepping. For example, if you have activated half stepping, with each step pulse, the motor will rotate only half step. The step and direction pins were controlled by a microcontroller. For our case, it's an Arduino. If you connect a few more motors and program them to move in a perfect rhythm, then boom, you have a 3D printer. But that's not the whole game. There is another game changer, the ramps. The ramps is a shield for Arduino Maker to be used as a 3D printer control board. It directly fits into the GPIO pins of the Arduino and allows the easy access to 3D printer hardware like heatbed or extruder. There is a website where you can find all the information about the ramps board and its components. I recommend you visit there at least once. Now let's see what are the sockets in the ramps. In the power input socket, there is a high current line that is used for heatpad, motors and heaters, and there is a low current line for other devices like Arduino, the LCD or any sensors. The main power to ramps is given by the SMPS, which converts 220 volt AC to 12 volt DC. Then at the end, the Marlin firmware. It is the actual firmware that needs to be programmed to Arduino to be worked as a 3D printer. And Marlin is a very large topic, so I think it deserves a dedicated video for itself. So maybe it could be a topic for our next video.